Okay, welcome again, everyone, to the SQL webinar. I'm Drew Vry, and let's get started. So this webinar will be on the topic of Introduction to SQL. Today, we're gonna be covering SQL, which is a data query language, and here we have things with like definitions, data definition languages, structured data, data manipulation languages, and data query languages. What is SQL? SQL is SQL, which stands for Structured Query Language. It is a standard language for storing, manipulating, and retrieving data stored in a relational database. And usually, when we have small amounts of data, it's easy to do it manually by hand just by looking at it. But bigger companies and other things have gigantic databases with millions and millions of entries. And in those cases, you need something efficient and fast for a computer to be able to sort through these large amounts of data and be able to present them in a way that other people can analyze them easily, which is where SQL comes in. Why SQL? SQL can query databases in a variety of ways. It has lots of different features that can efficiently sort through and perform different tasks on large amounts of data. It requires little coding knowledge, and it has a standardized language which works across different databases. And what I mean by this is the logic is pretty straightforward. Um, you're not really doing much complex logic or anything like that. It's simply just fetching data, retrieving it, things like that. And if you guys have any questions at any point, you can put it in the Q&A chat. Okay, now let's look at structured data. Structured data has a well-defined structure. Structured data is stored in the form of rows and columns. It is the foundation of relational databases. It is easy to access and query. Ensuring security to this type of data is easy. Maintaining data, such as inserting, updating, deleting from the database, is also easy and straightforward. So here is an example of a structured data table. Over here, we have lots of columns or fields, and each field has its own data type, which we'll cover later on. Each field also has a field name, and under that name, we have lots of data of the type which is specified by the name. Then we have rows or records. Each row goes through all the fields and has data for each field, corresponding to each field. And then we have values, which is um which is the data entered at a specific row and at a specific column. All this together combines to form a structured data table. So these are some data types. And as I mentioned, one field can have one data type. And by that I mean you can have one field with numbers and then dates and also like sentences all together in the same field. Each field will have its own category and you won't be able to mix and match. And here's some examples of specific data types. We have a char, which stores a single character, for example, A. So if your field has a data type char, you'll only be able to store one character for every value in that column. Then we have varchar, text of various lengths, for example, California. Next up, we have integer, which, by the way, how it sounds, it just stores integers. Example is the number one. And now, if your field has a data type of integer, you won't be able to store, for example, a word or a letter in there. Next, we have double, which is a number with decimal values. An example of that would be 5.25. And then you can also have a data type of dates, which by the way how it sounds is just date values. For example, 2022 710. And then we could have timestamps, which is date and time. For example, 22 710 at 13/21/12. And there are a lot of other types too, which is not listed in this table. I could go on and on. For example, text, boolean, tiny int, blob, etc. Data types. Data types define the kind of operation that can be performed on the fields. For example, if your field has a data type of integer, you'll be able to perform math operations, for example, addition, summation, average, etc. If you have a varchar field, you'll be able to perform text lookups. If your column has a data type of date, you'll be able to find and analyze monthly trends, yearly trends, and also perform date operations. Okay, databases. Databases is a collection of organized data tables, and this is an example of a database over here, where you have an employee with different attributes of the employee with name, job title, phone number, etc. Then we have a department of which the employee is, department ID and name, and then we have a project of which the employee is, a project ID, project name, which is also included in the employee's description. Data definition language. It is used to create and modify the structure of databases and tables. So first we have create. This is a syntax to create a new table. You're simply going to type create and you're going to write table, which is what we want to create. And then you're going to give the table a name. In this case, we're naming it sales table. And create, so when you write create table sales table, you're basically telling it to make a new table in the database and name that new table sales table. And now in these parentheses that come after the table name, you're gonna have all the fields and the data types of the fields. For now, we're not gonna worry about what primary key and not null is. If you guys want to know, primary key basically it does overall it doesn't let duplicates allow it doesn't allow duplicates in the same column, and not null requires um every value in that field to be filled. But anyways, within the parentheses, we're gonna put the name of each field in order. So the first field in this case would be text ID, and the data type of that field, int. So now that we typed create table sales table and we said text ID int, we just created the first field with text ID as the name, and the data type of that field is int. So we can only store integers within that field. And then we could just simply put a comma and just list all the fields and data types we want. So the second field we want to be called sale date, as we see is made over here, and the data type of this field will be date, as specified after. And then we throw in a comma. We have product type varchar 25, comma, item quantity int, comma, item price decimal. And of course, these things in the parentheses are specifying like how long the decimal is, how many decimal places you have, things like that, just like getting into specifics. Now we're going to look at the modify features. We can modify an already existing table using SQL. You can add or remove columns. You can modify column types. You can rename tables and columns. So first we're going to look at the alter command. So we're going to write alter table. We're telling it what we're altering. We're altering a table, and now we have to tell it which table from the database we're going to alter. So the table name, which in this case is sales table, which is the table we just created. So alter table, sales table. And now we're going to say how we want to alter the table. We want to add, and we want to add a new field. The add command basically adds a new column or new field to your table. Now we're going to name the column that we're adding, which is item revenue. And now finally the data type of the column, which in this case is decimal, and 10 2 is specifying how long and how many decimal places you have. So once again, the syntax for adding a column is alter table and then table name, in this case is sales table. How we want to alter it, we want to add a column, so we're going to write add, name the column, item revenue, data type of the column. That's it. And now if you can also change the data type. So as you can see, we're going to alter table again. name of the table, sales table. And this time, because we're not adding a new column, we're simply changing it. We're gonna use the change command, and then we're gonna say what we're changing. We're changing a column, the name of the old column, item revenue with three E's, which we just created, and what we want to rename it to, item revenue, and the new data type of it, which in this case is decimal 12.3. So once again, we're gonna have alter table, table name, the command, what we want to do, add, change, etc. What we want to do it on, we're gonna do it on column and the column name, and then the new column name and new data type. And then as you can see by the end, we have a new column called item revenue, and we renamed it to the correct spelling. Now we're gonna look at table copy. This is used to create a copy of an existing table. And this one is pretty simple. You're going to create table sales copy just like we did before. But now instead of putting parentheses and specifying different fields and data types, you can just simply use the like command and say like sales table, which is a table you want to create a copy of. So now you have a copy of sales table stored in a new table called sales table copy. Now we have drop. This basically removes a table from your overall database. So if you do drop table and the table name, we simply just deleted sales table copy from our database. And now we're going to look at rename. To rename a table in database, you're going to use the rename command. We're going to say rename table, name of the old table, or the old name of the table, original name, which is sales table. You're going to use the to command, and it's going to go to sales table, the sales data table, which is the new name you want to give the table. Okay, now we're going to move into data manipulation language. Okay, data manipulation language. It is used to add and update data in tables. So let's look at insert first. If you want to insert a new row into an existing table, you use the insert command. So before we learned how to add a new field or new column, and now we're looking after we created our table, we have all the fields we need or the fields that we're looking for. We want to start entering values in new rows. So first we have to insert a new row. And for that, use the insert command. So the keyword insert basically creates a new word. You're going to write insert into and the table you want to insert a row into, which is in this case sales data table, the table name. After you write that, you're going to write values, and in parentheses, you're going to give the values in the same order as the fields you want them to go into. So for example, let's say this table is originally empty, and we call insert into sales data table. Values 1. 1 is going to go in the first field. 2022 710 is going to go into the second field. Xbox will go into the third field. So as you can see, the order of the values you enter here corresponds to the order that it goes into the table. And another thing to be aware of is making sure the data types are right. As I previously mentioned, the data types of each field is specific. You can't mix and match different data types within one column. And similarly, when you're entering your values, you also need to make sure your values are lining up. For example, text ID was of type integer. So when we're entering values, we must make sure the first number of our values is an integer, which in both of these cases is true. 1 and 11 are both integers. The second, and then once again, the sales date, previously when we created it, we said the data type of that is date. So then our second value in both of our queries must be a type date, and that just goes on for the whole thing. And then once again, the syntax is insert into table name values and simply list the values you want to insert in your new row in order. And that is how you add rows into an existing table. Okay, I see that I've a few questions. I'm gonna take a second to just respond to them real quick, and then we'll get back to this. Okay, I also got a question in a private chat, and the person asked what decimal parentheses 10 comma 2 meant. So I'll go back to that slide real quick. Okay, for example here, decimal 10 comma 2. That basic decimal was our data type, and we're specifying a specific size of the decimal. So the first field of decimal basically means you can have 10 digits. And then the second field basically means you can have two numbers after the decimal point. So decimal 10 2 is basically saying this field accepts data types decimal of 10 digits with exactly two decimal numbers after the point. And similarly, decimal 12 3, what we change it to, basically says that we're accepting decimals of 12 digits and three numbers after the decimal point. Okay, so now let's get back to insert. So we covered how to insert into a table, and now we're gonna look at updating values in existing rows. So let's say we already have an existing row that we just created using the insert command, and now we want to change something in there. For example, let's say that the quantity of Xboxes just changed, and now we want to update that in our database to reflect that. What we do is we use the update keyword. So first you write update, you tell it which table you want to update something in, which is sales data table. Then you're going to use the set keyword. So you're going to set, and then you're going to give it you're going to tell the field you want to change, which is item quantity. You're going to say what you want to change it to. You want to change it to 3. And you can list multiple things. So you can say item quantity set to 3, and you can say revenue equal to 449.97. So simply just list the different fields you want to update and list the numbers you want to change it to. And the next part is important. If you don't have this, it won't if you don't have the where command, it will not filter your data. It'll do this to all the columns. Where is telling you specifically which rows you want to do it to. So when you write where, you're going to say text ID equals 1. What that does is it will only apply this command, set item quantity to 3 and set item revenue to 449. It'll only apply that command to rows where text ID equals 1. In this case, we only want to alter this row, which is the only row with text ID 1. So it is going to change item quantity to 3 and revenue to 449.97. But if we had multiple rows, let's say another row with text ID 2, another row with text ID 3, it would not alter those because it is only updating the values of rows with text ID equals 1. Let's say we have this row with text ID 1, we have another row with text ID 2, a third row with text ID 1, and a fourth row with text ID 5. It's going to update two rows, this row and the other row with text ID 1, and it's going to set both of their item quantities to 3 and both of their revenues to this number, 449.97. Okay, now we're going to look at delete. So to remove, you can remove or delete a row or multiple rows from a table. So you're going to use the keyword delete. You're going to say from and the table name. So delete from sales data table. And now once again, we're going to filter out and tell it which rows to delete. You're going to say where text ID equals 11. So in this case, we don't have anything with text ID equals 11 over here. So it will not delete. But if we had something with text ID 11, it would be gone by now. Now we're going to look at data query language. It is used to retrieve data from tables. This is where data users spend most of their time. Okay, we're going to look at the most basic statement first, which is a select statement. You're going to say, so if you want to just simply look at data and not alter it, simply just display the data that you're looking for, you're going to use the select statement. So you write select and you list out the columns you want to select. You don't have to print out a whole table if you're simply looking for information in two of the columns. You can simply select, write those two columns, and it'll only return those two columns. But after you list out your columns separated by commas, you need to tell it which table those columns are a part of, which table to get those columns from. So you're going to use the from keyword and give it a table name. So select list of columns from table name. Where? So it's gonna filter out the rows now. You don't have to display all the rows either. Maybe you're looking for two specific columns where, like, let's say the revenue is greater than 1,000 or something like that. You don't want to see the other rows, so you could say where and throw in filter conditions. And order by can easily sort your answers based on a particular column. So let's go dive deeper into that. Look, this is the most basic command you can have, and star is basically a special character which stands for all columns. So instead of listing out columns, text ID, sales data, sales date, product type, item quantity, etc., you could just use star. So you could do select star from and the table name, which is sales data table. What that does, it'll select every single column for you and display it. And as you can see, we don't have a where filter. We're not filtering any of the data. So it'll simply give us all the rows we have. If you want to retrieve the number of rows, you could use count. So you could select count and then star means just of once again of all the columns. Um, total row count from sales data table, which is the name of our table. If you want to retrieve specific columns, as I said, you can simply just list out the columns. So instead of saying select star from sales data table, you could say select, list the columns you want separated by commas. For example, sale date and item quantity from sale data table. And as you can see, it only returned the two columns that we are interested in. And you can retrieve specific columns from the table ordered by item quantity. So basically, let's say we want to only look at sale date, product type, and item quantity. We could do select sale date, product type, item quantity, once again separated by commas, from sale data table. Order at the end, we could write order by item quantity, which basically sorts it based on the numbers and item quantity. It'll sort the whole row, all the rows based on the numbers and item quantity. And that DESC stands for descending. If you don't write anything and just say order by item quantity, it automatically does ascending, I think. But then if you specify descending, it's gonna sort in descending order. Okay. Um Next we have select. Retrieve specific columns from the with product of Xbox only. So basically, as I said, we could use the where command to filter it through the rows and only look at certain rows. So let's say we want to look at the sale date, product type, and item quantity of Xboxes. You could select, list the three columns we're interested in, separated by commas, from sales data table. Where product type equals Xbox means it will only return um, the rows where the product type is Xbox. It'll omit all other rows that don't have a product type of Xbox. And the where clause has a lot of possible filters, and this is a list of a few. It you could for the first one you could have is where product type equals Xbox, which is what we just did, the equal to command. Then we can have where product type like XB percent. Percent is a wildcard, and you can replace percent with any number of letters or numbers, any number of characters basically. So it would accept XB. It would accept any row with product type of XB. It would accept any product row with product type Xbox. It would accept any row with product type Xbox 235. It would accept anything with XB 7F, literally anything in place of the percent. However, if something is before the X, it will not accept that because there's no percent before. It must start with X and B. That's what the like command does. And then you can use the between feature. For example, you could look at sale date between 22/7/2 and 22/7/10. It'll make sure that only rows with sale date between those two dates are shown. If it's too early before the first date or too late between the latter date, it will be omitted from the result. Then you have the AND operation. You could say where item quantity is greater than 2 and product type is Xbox. Basically, you can give it two filters and combine it with an AND. It will only return the row in the final result if both of the filters are true, if both of the clauses you gave it are true. On the other hand, there's a OR filter. You could say where product type is Xbox or quantity is less than 5. So if you give it two filters and combine it with an OR, either one of them has to be true for it to be in the answer. The only way the final result will not include a row with an OR filter is if both of the filters are false. If product type is not Xbox, but you still have less than 5 items in item quantity, it will return. Or if product type is Xbox, but you have more than 5, it will still return. If product type is not Xbox and you have more than 5 in item quantity, that's the only way it'll not return your final output. And then yeah, and then I can keep going. There are other so there are lots of other things you could do with a where clause. For example, in, not in, etc. Now we have select limit. It'll retrieve a specific number of rows. For example, if you have a huge database and you're just trying to look at how it's overall structured or something like that, you could limit it to the first 10 for the first 5 rows or something like that. So let's look at how you would do that. We do a normal select statement. For example, select sales aid, product type, item quantity, which are the fields you want to select from table name, sales table. Filter out only Xboxes where product type is Xbox. And now let's say we don't want to get all the results. We excuse me. We only want to limit the rows. We could say limit 10 comma 5. And this basically says get only 5 rows starting from the 10th row in the result set. So as you can see here, this would have been the 10th result, and we're only going to get the next 5. Now we're going to look at joins. A join clause is used to combine rows from two or more tables based on a related column in between them. For example, we have orders here that are the fields orders, customer ID, order date, and revenue. And over here, we have customer ID, full name, and state over here. So as you can see, both of these tables have a similar column called customer ID. So we could join on customer ID and overlap all the information based on matching customer IDs and make one combined table with all the other fields. Order ID, customer ID, order date, revenue, customer ID, first name, state. So let us look at inner join. There are different types of joins, and the first one we're going to be looking at is inner join. Um, Inner join returns records that have matching values in both tables, well, based on the column that we are inner joining on. And what do I mean by that? So let's look at this example over here, where we have orders and customers once again, just like the previous slide. Let's say we want to inner join on the column of customer ID because customer ID is what is overlapping. And this will be our final result of inner joining on customer ID. As you can see, there are only two rows in the answer, and that is because it only returns rows where a customer ID that exists here also exists here, where they're overlapping in both of the tables. So customer ID 2 does overlap in both the tables. So the row with customer ID 2, order ID 11 is returned with this order date, revenue of 120, and that is now merged with customer ID 2 from here. His name is John, and the state is New Jersey. That is all merged. Then our second field is customer ID of 3, which does not exist in customers. And because we're doing an inner join, we need it to exist in both of the tables, so that will not be returning the result. Then we have a customer ID of 4, which does overlap. So we are going to return that in our final answer. We have order ID 13, customer ID 4, this date, revenue is 90, and that is now joined with customer ID 4 from here. His name's Derek from New York. And then finally, we have another customer ID 3, which does not overlap. And similarly over here, 2 and 4 overlapped. Customer ID 5 does not exist in the orders table, so that does not overlap. And this is our final answer. This is our final result from an inner join of these two tables on the customer ID columns. Now we're going to look at left join. Left join it'll return all the records from the left table and the match records from the right table. So what think of it as basically an inner join plus all the rows of the left table. So the only rows we're omitting are rows from the right table that are not overlapping with the left table. So let's start with customer ID 2. Customer ID 2 does overlap in both tables, so we are going to um, return that here. Customer ID 2. Customer ID 3 does not overlap, but because it's in the left table and we're doing a left join, it is still going to be returned. So customer ID 3, order ID 12, and all of that will be returned. And the right side will be blank because, of course, it doesn't exist in customers. Then customer ID 4, that customer ID 4 does exist in both. So once again, it's overlapping, and we will add it to our final answer with the information over here. And customer ID 3 does not exist, but again, it's a left join, so we're adding everything from our left table, so it will still be included in our answer. And over here, as you can see, 2 was already added, 4 was added because they overlapped, but because it's a left join and not a right join, 5 is not overlapping, and it's not in the left table, so this will be omitted from our final answer. And now similarly, we have a right join. So I think you can guess what it does by its name. It's basically instead of it's basically a left join, but instead of adding everything from the left table, we're gonna add everything from the right table and only overlapping numbers from the left table. So as you can see, because it's a right join, let's look at the right table. Customer ID 2 overlaps, so we'll add that. Customer ID 2, order ID 11, all that stuff. Customer ID 5 does not exist in the left table, but we're doing a right join and it's in the right table, so we're going to add it anyways. We're going to add 5 Smith, New Jersey. Customer ID 4 overlaps in 2 of the rows, so we're going to add both the rows. So order ID 13, customer ID 4 with all that. Order 14, um, customer ID 4, and all the other information. So now we're going to look at full outer join. This returns records when this returns all records when both left and right tables. So let's look at our orders table over here. Order ID, we have order IDs 11, 12, 13, and 14, etc. And customers over here. So as you can see, it's gonna whether each row overlaps or not, it will basically be included in our final answer. We have customer ID 5, which does not overlap, still added here. We have customer ID 3, which does not overlap, still added in our final answer. And we have all the overlapping customers also added in our final answer. Okay, so let's look at the syntax. So select O dot order ID, O dot customers. What the O is basically the table because we have we have multiple tables that we're considering in one query because we're joining two separate tables together. So we're gonna tell it from which table we want order ID from because it could be confusing if both the tables have the same, what do you call it, the same column names. We could specify we want order ID from table O, customer ID from table O, etc., and just go down like that. And then from orders O, which is the first table, and what we're going to perform is an inner join with customers C onto O dot customer ID equals C dot customer ID. What that means is we are performing an inner join based on the columns customer ID from table O and customer ID from table C. Um, so it's only gonna return values where they're both equal. And we can also filter it once again where C dot state is New Jersey. So the state within table C has to be equal to New Jersey for it to be in our query, for in our result. Okay, now let's look at unions. The union operator is used to combine the result set of two or more select statements. So as you can see here, we have select product type, which is the field name from table name, and we filtered it for item quantity to be more than 5. So let's say these are the three product types that came out. And then we could say union, select product type from this where revenue is 500. So what this is the result of our second query, which is Xbox, and we're simply joining that to the result of our first query to return all four together. And union also, as you can see here, union only returns distinct values, which means it will not have overlapping and repeating values. If you want to see overlapping and repeating values without it filtering out distinct values, you have to use the keyword union all instead of union. And now we have intersect. The intersect operator returns only common rows returned by the two select statements. So let's say select product type from sales data table. So once again, select all the information in product type column from the table sales data table CSV, but only select the values where the quantity is more than 5. So let's say that returned a big list of different product types, and now we're going to intersect that with select product type from data table when where item revenue is greater than 500, and let's say that also returned a bunch of things. And because we use the intersect command, it's only going to return the product types that are true for both of them. So think of it like an AND operator. Okay, now we have group by. The group by statement allows rows to have the same values into rows with unique values from the column. So, for example, over here we have lots of separate IDs and lots of fruits. But you can see we have repeating fruits. We have apple over here, orange in number 2 and number 5. So if we group by fruit, we could simply have distinct values in the column fruit instead of having like a lot of overlapping ones. So this is really useful when you use it with another function on another table, for example. In this case, we're gonna use a function sum. So basically, if we wanted to count the number of apples or the number of every single fruit, we could use the sum function on the ID column when we group by fruit. So as you can see, when we group by apple, we have the sum is 2. We have banana is 1 and orange is 2 because there are 2 oranges, 2 apples, and 1 banana. And you can of course use the count function for that. So this is the syntax of group by. Once again, you're going to select product type and and then you could select the sum of item quantity, total item quantity from table name. And we're going to say to group what we want to group by. So we're going to use a group by keyword, and then we're going to say product type. So then it's going to go and collect all the product types together, the distinct product types together, and then it'll return the total item quantity, which is the sum of that item quantity within the product type. Yeah, and then this is another group by example where we have sum of item quantity stored in a column called total item quantity. We have the average of item revenue stored in a column called average revenue from this table, and we're selecting all of that. And if we group by product type, once again, we'll have all the distinct PC product types will be together with a total item quantity of 103 for all the separate PCs put together. And the average revenue is 778. Once again, average of all the PCs that were previously separately listed. Same thing for PS5, Switch, and Xbox. And let's dive deeper into group by now. So here we're gonna select product type, item quantity, sum, total revenue, same thing. And we could use a filter before the group by using a where command. So we're gonna say where product type is Xbox. So now we simply filtered out the product type of Xbox. We're omitting Switches, PS5s, and PCs, and we're gonna group by product type and then item quantity. So you could have multiple fields in a group by, and what that'll do is that'll group up all of the first column, which is product type, and then within that, it's gonna have the item quantities also grouped, which is, for example, item quantities of 2 with the total revenue of 299, item quantity 3, 449, etc. And now we're gonna move on to the live demo for SQL. Okay, I just shared my screen. And we're gonna be doing a live demo using SQL on a database, and today we're using SQLite for that. So over here, we clicked on database structure. Right now it's blank. So we could click new database, and we'll for file name we'll call it demo for now. And as you can see, right now we just created a new database, but we don't have any tables, indices, views, or anything. So right now we're gonna see we have 0 tables, and We could go to execute SQL. Okay, and I just pasted some SQL from one of my other files. So as you can see, first we're going to start off by creating a table, which is going to be named first table. And these are the different columns we're going to have. Column ID, name, grade, and marks. And the data type of each column, integer, varchar, integer, and integer. So if we just run that, it says, as you can see in the bottom, it says query successfully executed with all of the fields that we wanted. And now, as you can see under tables, we have a new table called first table with all the fields we wanted: ID, name, grades, and marks. And yeah, as you can see over here, we're visualizing the table with the 4 fields, but we have not inserted any rows yet. It's still empty. So now let's execute select star from first table, which once again, select star stands for all columns from table name as first table. And because our table is empty right now and we don't have any rows inserted in it, it's the final output says 0 rows returned from first table. Now we're going to insert 4 rows into our table with the values once again listed in the same order and following the data type restrictions. So we executed that and it says successfully inserted into our table. Now if we look at the table, we have all the 4 new rows that we added with the corresponding values. Now if we run select all from first table again, it returns us 4 rows, all the rows that we were looking for. And let's say we just want to select 2 of the columns, name and grade from first table. We could do select name, grade from first table, and as you can see, it only returned what we're interested in. Now let's say we want to update first table, and whoever has ID 33, we want to set their name to John. So as you can see before, his ID 33's name is Smith, and we would like to update that to John. So we're gonna update table name, set name John, and we're gonna use the where filter to say to only apply that to things with ID of 33. So we just ran that and it ran, and now let's select all from table again. And as you can see, the name is now updated to John from Smith. Now we're gonna use update first table. We're gonna do set name equals name or is good. And now we're gonna run that, and then once again select all from table, and then as you can see, it appended to the end of name. It appended is good to the end of the names. So now we're gonna use some math functions. We have the max function, which we put a grade field in, and we're gonna store it in the column name of max grade. So we ran that, and now we're gonna so now we're gonna select max from the table, and if we run that, as you can see, it's 11. So now we're gonna select multiple things. We're gonna select the grade field, the average marks as a field called a marks from first table, but this time we're using the group by command to group by grade. So it's gonna combine the grades together and return the results with the same grades and the average marks of that corresponding grade, which in this case is 10 and 11 with their average marks. Now let's say we want to delete the person with item ID 33, which in this case is John. So we're going to delete from first table where ID equals 33. So we're trying to delete John from this table. So we ran that and it says successfully executed. And now once again, if we run select all from first table, he's not there anymore. So now we only have 3 rows. And now we could run a drop table command too. So if we want to drop table first table, which is a table we already made, and now we go and try to select all from first table, it says no such table because we just deleted our first table from the database. And now we go back because we just dropped the table, the number of tables is back to 0. Okay, and that is it for the live demo. Okay, so that is basically all that we were going to cover today. So here's some next steps you can take to advance your SQL journey. You could look you could dive deeper into SQL analytic functions with things such as row number and rank. You could look at different keys like primary key, secondary key, and foreign key. You could dive deeper into data security, providing table access to different database users, granting and revoking permission. You could look at transactions, committing, and rollbacks. Okay, thank you guys for attending this webinar. I hope you learned a lot more about SQL today. You can reach out to me at dhruv.rai@hsnavigator.org with any questions, concerns, or anything. And also feel free to connect with me on LinkedIn. I just have my LinkedIn posted on this last slide, linkedin.com/in/dhruvrai. And have a good day. If you guys have any last minute questions, feel free to still put it in the Q&A chat. We'll still answer them. All right, thank you guys for joining. Have a wonderful rest of your day and enjoy yourselves.